Thank you. So again, as Gene just said, my name is Yuval Schhory. I'm the head of product management for everything cloud security with Checkpoint. And today I'd like to talk a little bit about what's different in terms of cloud deployments and why do we need machine learning and AI so much in these spaces of cloud security in order to really effectively shift everything that we do to the left. Now, when we say cloud, it looks like one thing, right? Let's just push everything to the cloud and get on with it. But we do need to understand that for different people in the organization and different people within the security organization, cloud is actually different layers, right? With different security needs, and it actually means different things. The thing that connects everything is the fact that it all need to operate at cloud speed. And I'm probably going to use the term cloud speed multiple times. First, we need to build an infrastructure. The infrastructure could be networking, security infrastructure, and on top of it, we're going to put some moving cogwheels like virtual machines and containers and serverless functions, et cetera, et cetera. But we're actually, when we look at what is of interest to the CIO, the CISOs of the organization, they're usually very focused on the web interfaces. And those web interfaces could be end user web interfaces or API interfaces. And the reason is because a lot of organizations go through digital transformation. The web interface is becoming their storefront or their revenue generating interface. And from an API and web service perspective, a lot of digital transformation that takes place in the supply chain actually use APIs in order to really push everything that needs to be updated from a supply chain partner and vice versa. One thing that is kind of across the board is the fact that everything across these different layers is deployed through a CI/CD pipeline today. Could be new entities on the infrastructure. It could be new virtual machines, new serverless functions, and of course new applications. So it doesn't really matter if you want to deploy a new firewall, you want to deploy a new container, or you want to deploy a new app. Everything is going to be done through CI/CD. Now, cloud actually is a serious thing when it comes to security, and based on the Verizon data breach report that was released this year, we see that cloud security breaches actually surpassed this year the on-prem security breaches. And we all know the stories. We heard about Capital One, we heard about Swiss Cloud and others. And I think that Swiss Cloud, by the way, is an interesting one because it's on their way of trying to secure against the OWASP top 10, they deployed the web application firewall, but it was misconfigured, right? And also they had some misconfiguration on the identity part, and that's exactly what allowed the adversary to actually access customer information. So we all understand that cloud is here. It's here to stay. It's not a matter of just like a couple of years ago when we said, "Are you going to move to the cloud?" There's no question today. Every CIO, every CISO I talk with say we're already in the cloud in some way or form. And as we go to the cloud, we need to understand that the attack surface and the threat surface actually are now as wider as they have ever been. So what really keeps the security people awake at night? First is the fact that due to the organizational shift left, they have very little visibility. And I think that most of the technological advancement in the last years actually pushed visibility out of the question when it came to the security side of things. Back in the days when I was a CISO myself, I remember that when an application was started to get designed, I was involved on day one. I was asked, like, what do you think? How should we do it? How should we build it? Today, security people are being called like one day prior to launch, where the DevOps and the dev team say, well, we built it. It's ready to go. Secure it. Oh, and by the way, it has to be ready by tomorrow. The next thing, which kind of is very connected to it, am I still relevant as a security person, right? If I'm not allowed to help earlier in the process and I'm just becoming almost like a bottleneck or a choke point for the business, am I really as relevant as I want myself to be within the organization? Next is something that didn't even change ever since first day of information security, which is how do I keep myself and my organization, my business off the Wall Street Journal headline and, replace Wall Street Journal with your favorite magazine where you like to read about, hackings and big things, right? Last but not least, this world really is becoming very complex for security people, again, because of their distance from where things are today happening, but also because there are so many new terms and new conventions that are for a lot of the development teams, a lot of the DevOps teams. For them, it's clear, right? But frankly, as a security person, when I first heard about serverless functions, for me it felt like black magic or something like that, or some kind of alchemy. Now, if we now take these things and we try to understand how do we fix on the cloud the challenge that we actually have, again, a lot of technical complexities. It's not just a complexity from hey, I just have a lot of things. First, we still need to segregate and segment cloud environments. We need to do it at cloud speed, right? So we are deploying network security threat prevention systems in the cloud. Next is how do I reduce the attack surface by making sure that everybody that is pushing something through the CI/CD pipeline is actually pushing an image or a VM which are compliant with whatever security best practices I want to use. It could be like a well-known framework, or maybe it's just the best practice where I actually decided what the best practice is. And I want to make sure that I'm doing it across multiple cloud. The way that we call it is do it just everywhere, right? Next is build microservices. Build microservices that together actually make up those applications. And again, those applications are what matters for the top management in most of the organizations I speak with. And this is exactly where we are on the inflection point between compliance and posture, which is more around the visibility of things. Tell me when something went wrong, with a possible automatic remediation if something went wrong. But the next thing when we talk about workload is actual runtime protection. And for those of you who are long timers within the security space, you probably remember the day when IDS became almost no longer relevant and the world was now the IPS world. We're not there yet, but we start seeing things that are really becoming similar to like an IDS to IPS shift. And customers say, yes, I have the visibility. I know what I have. I know what's compliant and what's not. I'm ready to move to the next step where it is, real runtime protection. Last but not least, remember we talked about the developers and the DevOps taking a lot of decisions. How do I actually empower them from a security perspective? And this is all about enabling continuous development in a secure manner. So no longer as a security person, I want to do things only when development has ceased, right? We're in, code is already being committed, but instead I want to make sure that I'm enabling developers and DevOps engineers to secure the code as they build. And if I'm giving ahead of time, I'm telling a developer, hey, just so you know, you're writing code, you're using a third-party library that has a vulnerability, or you forgot as you commit code into the repository, you forgot to remove whatever stale static authentication information. I'm enabling them to build better systems. And this is critical because security can't be just for the security administrator. It has to be relevant for the executive leadership on one hand, and it has to be relevant for the developer community within the organization. And when I say developers, developers and DevOps together. Now, when we look at those cloud assets, and cloud assets could be everything. It could be virtual machines, it could be containers, could be serverless functions, et cetera, et cetera. These are all islands in the stream. It's it's just pieces of a bigger thing, which is the application eventually. But now the question is, how do I make them really islands? And the reason I'm talking about islands is because an island is best protected when it's completely disconnected, right? If no one can get to it and you have to use, something together and there's no way to get to an island, then it's perfectly connected. It's perfectly protected. However, we need to understand that it's not really islands in the stream. It's not, VMs are not just standing in the middle of an ocean doing nothing. They are connected to different VMs. They are connected to different containers. They are connected to different serverless functions, and so forth within those assets themselves. So if I can't reach an asset, I understand it's not valuable. So it means that I need to build some kind of roads, just like the pinkish, orangish one you see in the middle. But how do I make sure that by making such an island, an accessible island, connecting it with different islands, that to make those applications, how do I make sure that I'm not using or I'm not allowing an adversary to use this this island as a jump board? And this is where Zero Trust could come to the rescue. But the challenge with Zero Trust that it says only what's a must should be allowed. But how do I know what's allowed, especially when I'm not there in day one to design the system, when actually developers push and commit new code without me knowing, when DevOps engineer deploy assets as things are being built and not me knowingly what's going to be there. And I think that it's clear we can definitely use AI to gather information from developers, to gather information from DevOps, but actually gather information from the system itself in order to make it actionable insights, something that I could really create a network policy, a security policy, an application policy, a permission policy. And the more data I'm pushing into the machine, the more accurate it is going to become. Last but not least, we can't, and I'll talk about a little bit about the old world ways of solving problems. We need to understand it's a new world problem. We have to have a new world solution. And I think that machine learning, artificial intelligence, that's exactly what we need in order to solve this new world problem. Now, let's talk a little bit about network policy. Network policy is actually defining which host, which asset could talk to which other asset and using what different protocols. Now, developers not only know what is being used, because sometimes, for example, they use pre-built libraries. When they use pre-built libraries, they don't really know. Well, they ask the library to do something, and the library goes out to the internet or goes out to another asset and fetch whatever it needs and return an answer to the code, and we're good. Another situation is where the lab is actually overly permissive, and it means that there is nothing that blocks anything. So then the developer doesn't even know what's being used or what is not being used. Blocking completely is not an option. Again, as I said, like, what good is an island if no one can get to it and no one can get out of it? We have to make sure that we have some kind of control around what's coming in and what's out. Documenting could be a tedious process. I'll talk in a second about what people use in order to document network security policy. It's a tedious process. It doesn't respond, it's static. It doesn't respond well to application changes, which, again, remember the CI/CD pipeline I talked about in the first slide? It's something that constantly changes, right? So we need something to document these changes and actually define this traffic that is necessary, but do it in a continuous manner. So how do we do it? So let's take a look at like almost a traditional security and DevOps and developers meeting where the security girl or person asks, what network security policy does your application need to operate? No one knows, again, because it's not part of what they do on a regular basis when they develop. And then and again, I used to do it as a system integration, as a system integration engineer tens of years ago. we used to just take logs from firewalls or from routers or from what have you, put it into an Excel file. Again, I'm talking about like 20, 25 years ago, and then run some whatever unique identification of different flows and build a security policy out of it. Surprisingly, the same top of the line tool is being used today. Like people just export logs and import it into an Excel or a different way of crunching data statically. However, this is not scalable and this does not respond well to changes. So what I want to now show you guys is how could we actually harness AI in order to reach this. So what you see here is actually an application built on containers, three-layer application, nothing that is too complex. And the question is, how do I know what type of traffic is flowing between each area and each host without documenting? So what we could actually do is discover the different containers, discover the different zones, right? It's done through downloading a Helm chart. I'm not going to take you through it, but definitely this is what you do. You start understanding what's happening on each node. Immediately, you understand what namespaces do you have, how many pods you have, what pods you have. But it doesn't look like the diagram we saw earlier. So actually what we're going to do in this zone, we're going to turn on access policy learning. And by the way, we do at the same time, we can actually also turn on things that are of the threat prevention type without even looking into anything that's being learned. I don't need to be a genius to use machine learning in order to understand that if your code tries to connect to a command and control bot, something is wrong, and I don't want to allow it. I'm going to disallow it on day one, right? But as I go learning, I can actually now learn within what's allowed. I could actually learn what different types of traffic and protocols are being used, right? And this is very initial. It's only after 1 hour of learning, right? And you see that the system says, hey, keep learning. But after it finished learning, it shows so many zones and so many pods, and it actually is capable of showing something that looks maybe with less colors, but looks similar to the same thing that we saw in the drawing. And this is something that the machine learning algorithm learned on its own, and then it suggests a security policy and says this is what you should use in order to support this. The nice thing is that as we move forward, actually new application changes will be relearned and reinforced. And we could also identify not only what's allowed, but also we can identify anomalies between this and things that are not allowed. It's not just a yes and no, is it allowed or not? It's much more than that. Now that we allowed we allowed some different islands from talking the wrong things and just allowing the right types of protocols to kind of pass between the islands. The thing is, okay, I'm allowing, for example, my serverless function to access an S3 bucket, but what does it mean? Is it enough to say, okay, this serverless function could access this other service? It's definitely not, because we have so many access types, and maybe the serverless function, for example, needs only a read-only from the S3 bucket. So do I completely allow everything, or am I actually allowing just read-only? And if I only want to allow read-only, how do I know exactly what is required? So how would a security person know exactly to take the right decision? And yet again, we have another meeting with the security person sitting together with the developers and the DevOps engineers and asking, like, okay, what permissions do you need on this database, on this S3 bucket, on this other serverless function you're trying to use while running this specific VM or serverless functions or what have you. And there's a lot of pushback. developers would say things like, well, yes, currently we only read data from the database, but what if I need to change something? Do I need to ask for your permission? I don't want to delay deployment of the new version because you didn't give it to me, right? And then the question is like, why are you so petty? Why do we need more than just this? Because I want access to the entire database. And the question is, how do I continue securing access but still maintaining agility and flexibility? And this is again where machine learning and AI comes into play. So let's look at actually, how do I take a Lambda function, immediately map the different using, just using static code evaluation, right? Sorry, static code analysis. How do I actually analyze and understand the Lambda function? What does it talk with? And then I can look at the IAM policy and say, okay, these are all the resources that this Lambda function accesses. Now, because I could actually take the code and run machine learning algorithms that model everything that the code might do and position them in different paths, in different journeys they could take against specific resources, I could actually tell you, listen, you're too open comparing what you really need and what you have configured. But this is not enough. As you remember, well, do I need to be petty and say like, oh, this is not enough? I want to tell you what's bad. Actually, you want, because the machine learning model actually modeled the required permission model and the effective permission model, not only I could calculate the delta, I could provide the security person a YAML snippet, which is exactly what the developers and the DevOps engineer use in order to configure those resources, right? And I can use it to provide the developer with exactly what they need to do in order to fix this, right? So listen, we got from not knowing nothing to knowing everything. Now let's summarize. We need to remember that we have a lot of data, right? And just looking at the data and having a developer or DevOps sending more logs to a SIM or something similar is not really going to add any visibility or insights, right? So what we actually need to do is we need to use machine learning and AI correctly in order to model policies and look a lot about how actual usage is being run, and then compare it to what's effectively configured and suggest changes. And this has to happen constantly. It's a continuous bridge that kind of bridges the gap between what security knows and what DevOps knows. And one last thing is, remember that, as I said, it's continuous. So when developers need to change something, it might change the requirement from a policy perspective. And with that, I'll bring it back to Gene. If we have any questions, more than happy to answer.